turn on the mic.
To start, the task of text summarization is quite intuitive. It is aimed at achieving shorter text which contains the gist of the input text. However, in natural language processing, there exists two types of text summarization: abstractive and extractive. And they are easy to understand in contrast. For example, the extractive uh, text summarization is performed by extracting important segments of the input text and combined into a summary, while the abstractive text summarization involves paraphrasing, synonyms, abbreviations, and changing the input text and overall creating like a new text, not from the input one. And this is an image showing these concepts. And this abstractiveness poses several challenges which are inherent to this task because when the task is to create a summary, it is quite difficult to understand which is the golden truth summary, because different people can have in their minds different mm, correct summaries for even the same text. And also, another problem is that this abstractiveness can foster hallucinations, because for the model, different words in the input text and in the summary on which the model is trained, the model cannot understand probably that these um, things are related, and it just learns to invent words that were not present in the input text. Um, and these hallucinations, especially factual inconsistencies, are very difficult to detect and to eliminate. One of the examples about the multiple possible answers to possible solutions for the summary is that when the text is long enough and provides um, long enough information, several people can interpret most important things differently. Even from the same text, they can focus on the different details, and this is an example that shows this concept. Um, the factual inconsistencies, which I mentioned earlier, they are a big problem for all generated text, but for summaries, they are especially the problem, because a summary should be based on the input text, and it is important that it doesn't contain information that is not true to the input. However, it is very difficult to find, and in the recent years, a lot of research was made on improving quality of text summarizations and on reducing the amount of factual inconsistencies. However, most of these works provided proposed solutions which required training separate models, and usually they trained separate models on data which the analog of which was not available for Ukrainians. So this research was not relevant to my situation. And there are some examples of approaches which are proposed to deal with factual inconsistencies, like training natural language inference models, name entity consistency models, and another possible solutions is to use ChatGPT as evaluator of the factual inconsistencies. Um, and another problem with this task is a limited amount of resources for Ukrainian language, because most of the research is done with English data and based on English data sets. So the results from other works can provide no additional use, because they require too much time and effort to reproduce similar things, and maybe they are even impossible because they're irrelevant due to differences in language properties. On this topic, there is, to my best knowledge, only one academic paper on summarization in Ukrainian, and it is mentioned here. And with in order to address in advance the problem which was highlighted in the review, this is only paper which described their approach at training model for text summarization, and I acted under the assumption that the link in this paper was broken and there was no access to their trained model, which was corrected in the second review. However, it was too late for me to change anything in the thesis. The first problem also is the data. There exist two publicly available multi-language datasets which include data for Ukrainian. However, they are deeply flawed, in my opinion, due to their approaches on which they are based on which they are made. The first one is massive sum, which uses meta description as a source of summary. However, this is not very useful because the meta description is not created to be a summary for humans. It is a search engine optimized text, and does not provide a lot of meaning in the context of a summary. And Excel sum and the paper on Ukrainian summarization use the same approach of dividing a news article into two separate entities of the first paragraph of leading paragraph and the rest of the article, and treating the leading paragraph as the summary. However, this approach is also not optimal, because while the first paragraph often contains the summary of the information, it also often contains some details that are not reiterated later in the text, because the writer of an article assumes that people who read the rest of the article have read the first paragraph of the article, and authors do not think that they have to elaborate on the details. So this dataset also includes a lot of mistakes, which are, for example, this is one example from the Excel sum dataset. Here are highlighted all words that contain the root nafta, and just to show that many details are lost if you treat the first paragraph as a summary, and there were a lot and like all of the text were similar way, and this is not only my assumption because there is an academic research paper which analyzed this multilingual summarization dataset and arrived at the conclusion that that it is of poor quality because they calculated the percentage of the provided summaries which are entailed by the which entails the text. They were supposed to be summary of, and they arrived at poor results. For example, we can see that for Ukrainian it is like 38%, which is not a good result. And for like almost all languages, the situation is the same. And my understanding is that this is a result of the wrong approach to creating such data set. After realizing this, the decision was made to assemble own data set, which will use more which will use more human-oriented summary approach. And the hypothesis was that with data collected with approach with users text intended, which were intended to be summaries, in combination with newer large language models, the results will be better. However, then there was a problem with how to measure this, because measuring the quality of summarization is a difficult task itself. And it will be addressed later, but for now I will describe the approach of creating custom datasets. The main idea was to use texts which accompany the links to news articles in Telegram channels, because they contain short summaries of the news that are in the articles, and they usually intended to be a short summary. To achieve this, several news media companies were selected, with the selection criteria being that it should be a company and not a single person blog, because when it's a person's blog, there are more emotionally charged and emotionally charged sentences, and usually companies try or at least should be more impartial. And one of the criteria also was that the summary was not just a repetition of the leading paragraph of the article, because it was also present in some cases. The selected were Суспільне новини, Громадське and Espresso. And this is an example of a summary article pair that was generated. This and later it was in order to filter out data, several dataset metrics were calculated, and it is also difficult because calculating the quality of the summary is a difficult task. In other research papers, there were a number of metrics that were used in similar situations, and I uh, used several of them. For example, the basics were token statistics like uh, number of tokens, ratio between number of tokens in the summary and the text, amount of sentences. Another approach was fragment-based, which measures the overlapping fragments between summary and the reference text. And this approach was proposed by a research paper which introduced a new data set, and these metrics were used to distinguish between text which were more abstractive or which were more extractive. So the metrics like show how much of the words in a summary uh, are um, are overlapping with the words in the reference text, and for example, density shows how long are these overlapping fragments, and can indicate that there are multiple words or even sentences that are just copied from the reference text, which makes the summary less abstractive. And BERT score in order to try to capture semantic meanings from the words, and to understand whether the summary and article are um, um, speak about the same theme. And all of these metrics are not ideal. For example, this is an extract from one of the research papers which analyzed how well these metrics perform in relation to the human evaluation of coherence, consistency, fluency, and relevance. And we can see that the correlation coefficients are not that great, and this just shows that it is quite difficult to measure and quantify the quality of the summary. And there are some of these distributions of the values of this matrix of the created data set. And I already mentioned that this matrix not able to access factual consistency, and they're unable to distinguish between the hallucinations and just usage of synonyms and paraphrasing. And some metrics required modification for Ukrainian language due to, for example, the fact that in English the words are without inflections, and in Ukrainian there are inflections, and the meaning can be different when using different inflection, and this matrix will consider these words totally different. In my reviews, there were comments about the little amount of experiments that were described in the thesis. And this is because quite a lot of experiments were totally failed, and there was nothing to write about in the thesis because the results were not quantifiable. And the situation was that I was unable to understand whether this poor performance was due to my lack of experience with working with large language models, due to the fact that the models should have been fine-tuned for longer, or due to the fact that these particular models just required more fine-tuning in order to produce some results in Ukrainian. And the experiments approach was to fine-tune the large language model with quantized LoRa approach for parameter efficient fine-tuning. And this is an example of one of the first experiments, and this is like clarifications why there was nothing described in the thesis regarding this, because like and I focused on Llama 3 because this was a model that provided first meaningful results, which could have which I were able to describe to quantify results, and therefore these experiments were included in Thesis. The model was fine-tuned with arbitrary prompt like this because during my experiments I haven't found a prompt that would work without fine-tuning for Ukrainian language. Therefore, I did not discover prompt that would provide any additional advantage before fine-tuning. So this is format of the prompt on which I use, and like this is an example of one of the successful cases of summary generation in result of my experiments, and highlighted are words which relate to the same thing. And from this example, it is clear that the model can associate like job title and the person and use it correctly. It can make abbreviations. And overall, in my opinion, this is the example of a good summary. And later, this is another example in which there is factual inconsistency, which model created itself, and there is no data to prove this point. There are results, evaluation of results of my experiments, and overall they show that these metrics are not able to describe the quality of summarization because there are differences between much more drastic differences between, for example, experiment 1 and experiment 1, or experiment 0 and experiment 1, but the scores are not that different. However, they can be useful when comparing different experiments. For example, I highlighted the experiment 1 and experiment 3 because they have similar results, and they show that like using more data can achieve similar results with training for one more epoch and using lower amounts of data, because it was another problem which I encountered, that limited processing resources, and I was unable to fine-tune for long and use larger data sets. Therefore, these results can be used only as like preliminary results and some approaches that can be elaborated on and improved. And this is the and because while I think that in my work I confirmed the hypothesis, it is also clear that a lot of the aspects were not researched, and here are several things that that can be researchers achieve better results, which I unfortunately were not able to complete during my thesis. And this is all regarding this, and I can answer any questions.
Thank you. Who would like to start?
Can you please formulate in one simple sentence what is your contribution and what really have been done? What is the advantage of science after this work? Why I asking so? Because even in conclusions, it is very like unclear and to many it was unsatisfiable. It was a bad result. It was so. What is the real result in one simple sentence?
In one simple sentence, the main contribution is the proposal of a different approach to dataset creation, which was not present in other relevant works. And in my and the results that show that quite satisfying summaries can be achieved even with minimal fine-tuning of the model.
Okay, but even in your conclusion, you said that it has many problems.
Yes.
So is it a real result or is it some very first step to some result? How do you estimate it?
Uh, in answering these questions, I cannot provide a working solution. So, but it is a difficult problem, and in my opinion, with available resources, including the available relevant work, this is a contribution.
Let me argue against it because you mentioned you used very huge video cards. You use the best models available now. So what do you lack for? What is not enough to get these good results?
I suppose that um, the better results could have been achieved if I had an ability to train for more than 2 epochs and using more than 2,000 of summary article pairs. Unfortunately, after exceeding um, this number of summary article pairs, um, mm, there was a timeout, and I wasn't able to achieve results.
What reasons do you see that if you have more time, you can achieve better results? Because if even 1 or 2 epochs of training give you something good but not so good, as you state again in your conclusions, maybe next iteration would give you like um, let me say, jumping scores, yeah, something like this. Are you sure you will get better and better results? So you can get next iteration, you could get much worse result. Are you sure you will get better and better result if you had more resources, more time?
Uh,
For me, it's not obvious.
uh, um, in um, um, in my opinion, this can be the case because in experiment one, I trained the fine-tuned model on 2,000 summary article pairs for 2 epochs, and in experiment 3 I trained 5,000 summary article fine-tuned on the dataset of 5,000 summary article pairs, and achieved for only 1 epoch, and achieved the same results, like similar results based on scores and on overall my uh, human evaluation, and which uh, mm, by which I assume that probably if there were more epochs and more uh, data, because 5,000 is not a large data set, uh, this um, um, this gives me an impression that probably the results will be better. I stated that other data sets were a problem. The approaches on which multilingual publicly available data sets were created, I stated that their approach was wrong, and that it leads to hallucinations.
Thank you for your presentation. Have you seen the review of your work, by the way?
Yes.
Why did you dare to answer the numerous statements which are negative character in the review? Could you please go one by one through the criticisms listed in your review and try to defend yourself?
One that comes first to my mind is the absence of comparison with the benchmark, which I already addressed that in the second review. It was stated, I was given the link to the model on Hugging Face, which I did not know existed, because when I pressed on the link in the PDF of the article, it led to error, 404 error, and I did not notice that in order to access model, I just had to edit the link manually. And I don't know what to say about this mistake, because after I received the second review, I have asked myself this question many times, and I understand that this would not only improve my work, but also made my life easier. However, I could not do anything about it, and I only can say that the absence of such benchmark was not due to my lack of understanding that it should be present in the work. I truly believe that there was no access to any publicly available model.
Summarize.
In other reviews, I also understand that I had to elaborate more on my justifications of the approach I used. Um, in because from my thesis is not clear why I used the approach I used. And also, I remember that there were one of the reviews stated that my it is not clear which conclusions were made from overview of related work, and to which I can say that a lot of the relevant work review were not quite relevant because they were concerning only English and were not very relevant to the Ukrainian situation with Ukrainian language.
Excuse me. May I please ask you how many reviews did you receive?
2,
2 reviews.
yes.
Ruslane, to have the last review within the system? The final. Okay. Okay. So that was the question. That was the question. Well, in fact, this is the final review. Okay. Yeah, no, I do see that the recommendation of the final version of this review is also quite negative. Do you have an idea why the reviewer has evaluated your work so negatively?
Um, yes, I have reflected on the whole process, and I understand that I should have maybe emphasized different things in my thesis. And also maybe if there was a comparison with the existing model, the work would have been much better.
Okay, so can I interpret your reply that you agree with all the critical comments provided in the final review?
Mm, like,
Do you think the criticisms listed in this paper are fair in your interpretation? I'm just asking your opinion
in my
as a collegial.
interpretation, they are valid. However, I think that they uh, can be a bit mitigated with understanding that this is the situation with Ukrainian language is much more difficult than the existing doing research with the Ukrainian language is much more difficult than doing research with the English language due to lack of available related work on which you can base your own work.
No, we're not discussing the difficulty of the problem and the lack of resources. Yeah, Ukrainian is in under-resourced language, but I wouldn't really share your pessimism in terms of the difficulty of working with the Ukrainian language, because anyhow, there are plenty of tools that could be applied, which also allow you to work with Ukrainian using the same approaches that I used for English. But well, it doesn't matter. Okay, thank you. I'm done.
Um, yes. So I reviewed a text a little bit, and it looks like you use a kind of very trivial prompt. So just as resume text. Have you tried not a zero shot, but maybe few shot examples and so on and so forth?
Other longer prompts?
No, no, a few short examples. For example, so in your case, you didn't provide the model any example, but you can provide, for example, one short example where you give the full text, then summarize text, and then ask the model to repeat this process for the new text that you add.
I tried this and did not arrive at any satisfactory conclusions, and I just moved on to the fine tuning with this prompt.
And also, you mentioned about your kind of failed experiments with Llama 2 and Mistral, if I'm not mistaken. I just opened these models online, and it like tested Ukrainian, and it seems they have either no support of Ukrainian or very poor support of Ukrainian. So it's kind of expected that you get a poor result, like with no fine tuning. And then I tried Llama 3, and it works better with Ukrainian language. So that could be like your potential explanation. So you didn't have to just discard your experiments, but explain your experiments in your work. So master thesis shouldn't contain only positive experiments that give positive results. And my next command is that I see that most of your experiments are performed with Llama 3, 8B,
Mhm.
8 billion parameters, and it was released in April.
Yes.
And it was released in 18th of April.
Yes.
And the submission of the final text diploma is 17th of May. So it's just only 1 month for performing all of this experiments. So it's so very short, very short period of time. So how you, I don't know, can explain this? Because, for example, during the first day of defense, we had a student and she performed experiments that took 50 days if you aggregate it. And it's even more. So in her case, the experiments took more time than just running experiments took more time than 1 month.
Uh, I did not achieve any satisfactory conclusions before the Llama 3, so I and the experiments that were completed before were just not very good.
Yes, and thank you for presentation. Yeah, I have like maybe one more question regarding the architecture choice, because it seems like it is becoming popular to use LLMs for most of NLP tasks, but previously and in that work that you referred to with Ukrainian abstractive summarizations that was released in UNLP, the architecture which was used is MT5.
Yes.
And it is like smaller, so it will possible allow you to train longer and like use less resources. Yeah, maybe you can explain like the intuition why you have chosen such big models and like these llama family of models.
Uh, Probably I should have tested the MT5 approach also, but I acted under the assumption that that better results will be achieved with Llama 3 with large LLMs, and I experimented with them.
Yeah, maybe just a quick follow-up. And have you checked like some other academical papers that compare like Llama or other big LLMs with previous approaches like MT5, even on other languages for abstractive summarization?
In abstractive summarization, there are even for English there are not a lot of research paper, at least to my best knowledge, in the last year, and the ones that are, they focus on the factual inconsistencies and improvements of quality of summarizations. So I haven't found such research papers. Maybe they exist, but the ones I've read and researched did not contain any comparison, because maybe if there was a comparison even for English, I would have used different approaches also.
Okay. I think we are over time. Thank you, Yulia. The next student is Andrei Mironenko, and he will be first presenting and then defending his thesis that is entitled Improving Skill Extraction from Job Postings Using Synthetic Data and Advanced Language Models. And he was advised by Anna Peleva. So, Andrei, the best of luck.
Yeah, so good evening, dear examination committee. Ruslan already introduced me and my advisor, so let's go with the plan of my today's talk. I'll begin with the introduction and the motivation for my work. Then I'll present the results of the literature review, the gaps in the research that we identified, hypotheses and questions we formulated for the research, plan of the research, how it was executed, and the results. Then we'll briefly discuss how I addressed the reviewers' comments and outline the future work. So what is the motivation for my work? The skill identification or extraction could be used for many different purposes. For example, for job matching, for skill trend analysis, employee development, maybe some policy making. We believe there is untapped potential to utilize large language models for this task, and there is also a growing demand for AI tools in HR domain. The goal of this research is to analyze the performance of large language models applied for skill extraction, standalone, like why do we need a separate model if LLMs work? Then identify the ways how we can utilize the LLMs to actually improve the extraction, and compare the results of the improved approach to the baseline performance. So in order to actually understand this presentation, we need to get familiar with the terminology. So what do I mean by skill extraction? Skill extraction is the isolation of specific skills and knowledge required for the job in the job posting. So how do we understand what is skill and what is knowledge? We take the definition from ESCO. ESCO is European Skills, Competences, Qualifications, Occupations Database. Basically, what ESCO has, it has an occupation and the skills and knowledge that could be used for this could be related to this occupation. So in this ontology, knowledge is the result of learning comprising facts, principles, theories, and practices related to a specific field. For example, if we talk about IT, it could be like a programming language. For example, TypeScript, JavaScript, Python. If we are talking about skills, it is the ability to use knowledge to complete like tasks. For example, to present to the large audience. So we did a literature review and identified that currently several methods are used for skill extraction. It is sentence classification, skill spans recognition, and recently searched generative methods. Let's go with the skill span recognition first. In this problem, in this approach, we formulate this task as a named entity recognition problem. Essentially, we recognize the text spans that contain skills or knowledge related to a job in the text of the job posting. In this approach, we detect the skills raw as they are formulated in the posting, and typically done with encoder models like BERT. The problem for these models is we need high quality label data for training, essentially fine tuning it. And the primary metric is span level of one score. Then the next approach is sentence classification. In this approach, we train a classifier to actually classify a sentence as containing a skill or knowledge. It could be called like this approach, like extreme multi-label classification, because there are a lot of labels, and we need to classify a sentence as either having a label or not having at all. The problem here is the same, like we need to find training data to cover large ontologies. And the metric is R precision. And the last but not least, the recently surged in popularity, like LLM-related methods. Since the emergence of LLM, they were used we found several papers that try to use it for skill extraction. The most straightforward approach is to ask it to summarize job posting, extracting required skills in separate sections. But there is a problem here that actually we need to somehow evaluate it, and the evaluation is not straightforward. Also, as it was used as a synthetic data generator for sentence classification. So in this previous approach, the LLMs could be used to generate like a sentence containing a skill, and that could improve this classifier. As a part of classification pipeline as re-ranker, essentially classifier classifies to containing a skill, and we ask LLM if it's indeed in the sentence. Improved this approach as well. And to fine-tune smaller text-to-text models to generate skills, like to do the summarization, was done as well. Yeah, but also we didn't find the evaluation of this approach except from human feeling that it's summarized as well. So the research gaps that we found is there is no evaluation of LLM standalone performance for skill extraction. And also there is no study on how to use LLM-generated synthetic data within the context of sequence labeling in our approach, essentially the first one that I showed. And so we had the idea, what if we use open source labeled datasets to evaluate the performance of LLMs? What if we use LLMs to generate training data to improve performance of encoder-only models like BERT for skill extraction, skills spans recognition? Yeah. So our hypothesis is that LLMs underperform supervised models in skill extraction now, and that synthetic data from advanced why do we believe so? Because LLMs are optimized to generate text, not to extract the structured data from the text. And the second is that synthetic data that we can generate using these LLMs could improve the skill extraction performance. So which models did we choose for our experimentation? As LLMs, we chose GPT 3.5, GPT 4. Prior to this, we also tried to experiment with the open source model Llama 2, which was the latest at the time, but it wasn't able to actually extract structured data from the sentence as we tried. The reason, because high quality, able to follow instructions consistently. It's great, yeah. And the language model that we fine-tuned using the synthetic data is BERT-based. It's not like the most powerful encoder model, but it is suitable for fast training compared to the larger models because we have limited research resources. It is widely used as a research baseline, and it is good for sequence labeling. So how do we formulate the research questions? The question number one, could LLMs generate high quality data for skill extraction training? What are the most effective prompting techniques for this data generation? how far can we improve encoder models using this synthetically generated data, and how much data do we need to maximize the performance improvement? What data set did we choose for evaluation? The data set is called SkillSpan. It distinguishes skills and knowledge component as defined by ASCO. It is labeled by a team of several people, and yeah, it used the uh, definitions given by ASCO for this labeling. And it's important, and I want to stop here, that it consists of 3 parts: tech, house, and big, 2 of which are publicly released. So we couldn't use like this big part in our experiments. So we had to use only 2 parts. Tech contains IT-related job postings, and house contains like general domain. But because in the original paper, like they use 3 data sets and we can use only 2, we need to repeat the experiments in the original paper in order to get the baseline. We repeated it and got the following F1 score baselines. As we can see, the model is worse at detecting skills because skills are generally like longer and better at detecting knowledge. So what's the research plan? The first item, I've already told it. Repeat the experiment. Then we want to evaluate GPT 3.5, GPT-4 on the SkillSpan dataset. Then we want to establish a data generation pipeline for synthetic data to actually augment the training set and to fine-tune BERT using the combination of original and generated data. And then we want to compare the performance of fine-tuned and the original, like fine-tuned with the synthetic data and the baseline. So how did we evaluate the LM standalone performance on this data set? Well, we searched the like best methods of leveraging GPT for named entity recognition, and we found a paper called GPT-NER. It proposes in context learning using the examples from the training dataset while evaluating extracting data in the test sentence. So as you can see on the diagram, we select a sentence we want to evaluate. Then we select 4 similar sentences to the one that we want to evaluate using the embedding similarity. Then we incorporate everything into the prompt and get the result. We also, after the results, we used self-verification technique, essentially asking the model if the extracted span is indeed a skill or knowledge. And we also use in the prompts, we used the definition of skills and knowledge, from the ontology. So what results did we get? Well, the results were worse than supervised baseline. The common error patterns that we detected are irrelevant detections, malformed responses, and merged entities. Also, better performance, where the model showed better performance on knowledge rather than skills. We believe that because knowledge is easier to comprehend. And GPT-4, no, the GPT-4 was evaluated only on 5% of the set due to budget limitations. So once we got that the LLMs are not that great for the standalone detection of skills, then we went to the synthetic data generation experiments. We used the GPT-4 model for it, and we conducted 3 experiments. What is the main idea? We use the ontology ASCO, and we generate the context around the skill or the several skills or knowledge that we select from this ontology, that it sounds like a sentence from a job posting. Why do we think it will work? Because prior research says that 64.5 skill spans annotations have ASCO equivalents, that embedding visualizations of the skills and of the knowledge from ASCO and skillspan show the intersection, and there are also similarities in length and structure. So what did we try at first? Like why don't we generate sentences like without any knowledge of the training data? Why don't we just select random skills and knowledge and ask model to generate context around it? The problem was the following. It could generate additional skills and knowledge. It could generate like the sentence with the annotations, but it could generate and insert more skills and knowledge components because on high temperature settings, and essentially leaving it without the annotation. That is the problem because that is just like the noise in our data set. And on low temperature setting, it could generate it like consistently without any additional skills and knowledge, but it was not diverse enough. The sentences were like similarly structured, and that is proven by our self-blue score, which is 0.76. We'll see later that it is not that great. And we decided not to move forward with this approach like at all. We will not use it later. The second experiment is the synthetic data generation using the sentences from the original training set. What do we ask? As you can see on the chart, we have a original sentence. Then we select an occupation, a skill from there, or knowledge, and prompt large language models to rewrite the sentence, inserting a skill there, but only do minor adjustments to maintain coherency and consistency, like so that the sentence sounds good. And as you can see here, design information system skill was rewritten to designing information systems, and the sentence like is good. Mostly, this approach resulted in coherent and diverse sentences. Self-blue score in this like method is 0.46, which is around the same as the training data set in general. And we didn't encounter the cases when the model removed the annotation. And we decided to move forward with this approach and to experiment using it. And the third experiment is template-based generation plus rephrasing. What did we do? We got the results from the previous experiment, and asked LLM if the sentence is coherent and it makes sense for job posting. The LLM, GPT-4, answered like no in 13%. Then we asked it to rephrase it, so that's it more relevant for a job posting, but keep the annotations. And it rephrased it. We prompted it again using this validation prompt, and we found that only 4% of the sentences now contain are like detected as bad, and mostly that's because the sentences contain skills and fit for a particular job posting. For example, it asked like engineer with gardening skills or something like that. So once we have the data sets, the generated data sets, we decided to go with the fine tuning. What did we have to do? We ran 2 iterations of the fine tuning with the 20% of the site of the training data, the synthetic data taking 20% of the site of the original training data, and 40%. We had to balance synthetic data set with samples containing no skills. For it, we asked the model to rewrite the sentence, LLM, to rewrite the sentence containing no skill, essentially rephrasing it, and added it to the synthetic data set. And we trained each model, like BERT, we trained 5 times for skills and knowledge extraction separately using these synthetic data sets. And let's observe the results. First, let's see the performance on knowledge. To our surprise, the template-based approach without any rephrasing gave better performance. As you can see, especially on house dataset. Then there was no significant improvement in tech dataset. And yeah, that's it for knowledge. For skills, we had only marginal improvements using both generation methods. We didn't have any statistically significant improvements. Yeah, and mm, that's it. Next, we wanted to determine the optimal synthetic dataset size that would maximize the performance of the model. We, as template-based like method showed proven to be the better, we generated 60, 80, and 100% of the training data using this method. And we found that on 60%, the quality of the predictions is the best. Then it is deteriorated. Likely reason is overfit on non-ideal, like synthetic data obviously is not ideal. So let's observe the best results. As we can see, we got a statistically significant improvement on knowledge and skill detection in on-house dataset, essentially general domain. This we tested this statistical significance by doing t-test, considering that we have like five models trained 5 times. We repeated the experiment 5 times. Yeah, as you can see, skills detection is statistically significant, but it is like minor improvement. Knowledge is more is better. And regarding the tech dataset, yeah, we didn't achieve any significant improvements. So let's discuss the results. As we can see, standalone LLMs are insufficient for this skills extraction, and they are still underperform the supervised baseline. The synthetic data improved knowledge and minorly skill extraction only on house dataset. Yeah, likely reason like tech dataset was already saturated with the large amount of skills, and as house dataset is the more diverse, we added like more additional skills, and it got better. The quality of data was not ideal. 13% of template-based generations were incoherent, as we discussed before. And when we analyzed why the rephrasing doesn't bring the like improvement that we hoped it would bring, we found that around 1% of the rephrases result in the malformed sentences when the actually the skills are removed. And that was not that great. So let's discuss the comments we got from the reviewer. In the initial review, the reviewers argued that 2 data points, like 20 and 40%, are insufficient to make conclusions. After the initial review, we conducted more experiments. The reviewer argued that we interacted only with closed source large language models. We agreed that open source research with the open source language models is statistically scientifically more significant, but at the time of when we began the research, they were unfit for our experimentation, and the LM usage wasn't the best decision. Probably we could get a similar improvement without the usage of LLM. In hindsight, yeah, the results are far from what we expected initially, but yeah, there was no prior research done in this topic, so we experimented with it. So I wanted to reiterate our contribution. The future researchers who will focus on this problem are aware of the limitations and problems that we faced. They can also use the data that we generated and that is available in our GitHub repository. Then we did a comparison between LLMs, like standalone performance, and supervised baseline for this task. And we found that LLM generated data significantly improves knowledge extraction compared to the original model. So let's outline the future work. Ideally, we could repeat these experiments with better post-evaluation of the generated data. Also, it would be helpful to compare our results with the more traditional augmentation technique. For example, just swapping the entities with the ones from the ESCO. Then we could do more we can do more experiments with the open source large language models. Especially, it is interesting if we have if we can fine tune them for this like skill extraction task, and what will be the results there. And also more advanced prompting techniques for skill extractions by LLM standalone could be used, but the cost efficiency of this like task should be also considered, because more tokens, more money. uh, and many thanks for your time, and I am here and happy to take your questions.
Given that the microphone is already in my hands, uh, yes. So yeah. Thank you for the presentation. I have like a very general question, and I thought while you were presenting, I thought about solving approach how I would solve this task. So do I understand correctly that the database of these skills is finite? So yes,
Is what?
database.
Finite.
Yes.
Yeah. Yeah, it's frequently updated, but it's finite.
And how many skills are in that database?
I believe around 15,000.
Yeah, so I've kind of I have a feeling that, for example, job postings are position and direction dependent. For example, if I am IT guys, and for example, I can remove all my model shouldn't pay attention to all the rest skills except IT focused, right? And then I, for example, specifies that I am research engineer, and then my set of skills decreases even more. So um, uh, I'm curious, is it possible to solve this kind of by a brute forcing, or for example, um, uh, what I was trying to say, or is it possible, does this data set of job posting, does it contain some metadata, or only the description of the uh, job itself? So basically, let's start with this.
The original data set called SkillSpan contains only the descriptions of the job postings.
Okay. And another question, what is the input and output of your model that you trained?
The input is the sentence. Yeah, so the input and the output is structured in BYO format. Essentially, we no, we give the input, the sentence, and receive the output in BYO format, which essentially like the structured skills or knowledge. It outputs the tag if the word is a skill, or a word is a knowledge, or it's not skill or knowledge. Like it's named entity recognition.
And like my intuition, for example, about large language models, that they are trying to kind of really like extract and maybe match the skill to some previous skills they seen before. And maybe this models that you are training is trying to actually find the position where the skill is like placed most probably. Maybe kind of, do you have any intuition, and can you explain how the model works, and how it decides where to put the tag?
You mean BERT, the one that we trained?
Yes.
Okay, so it the model outputs the embedding of the word, and then it's fine-tuned. We have a classification layer on top of this transformer model that essentially that that essentially detects that essentially classifies this embedding as a skill, knowledge, or not skill and knowledge at all. But yeah, that's it.
So this model, when it trains, so it learns to remember all the skills during the training, or it learns the positions where it should, you know, put the next token mark as the skill.
I believe it learns the position where the skill. It's not just embedding the context as well.
Okay, thank you.
Thank you for a nice presentation. It's not. Oh yeah. My first question is about the thing that somehow passed by my consciousness. Why are you talking about named entity recognition in this context of your research?
Because mm, it's like how we formulate this problem. Probably it's better to call it like sequence labeling. So we have the, because named entity recognition problem is solved the same way with
just
this.
because you use a very similar method.
Yeah,
Okay.
essentially.
Okay.
Yeah.
Okay, my second question is a little bit provocative. What's your intuition about the reasons to have this close to negative results in your research?
Why do I get
Why the models you tried? I'm speaking about the LLMs, which do that so miserably poorly.
If we are talking about the large language models?
Whom to blame?
Okay.
An LLM, all the five, or you as a prompter?
I believe that I believe that we can blame the model because we tried we tried different prompting strategies, and for example, we tried longer prompts, including more information, more specific information about the skill. Yeah, I blame the ability to follow the instructions. So essentially, the uh, ability to follow of the model to follow the instructions, the instruction of the skill detection, precisely, is still worse than the when we train a separate model designed especially for it, designed specifically for it.
But if you wish to know about my opinion and my interpretation of that, of the reason, I do believe that you deliberately chose lazy prompting. If you have added more specific semantic information, the semantic context of to your prompt, my backbone says it will yield much better results. Have you ever thought about that? Did you try it?
Yeah, of course, we thought about it, and the original data set, SkillSpan, could have the annotation guidelines released. Initial, our idea was to just put all this annotation guideline into the prompt.
Yep.
And we got worse results than the shorter prompt containing like the more specific information. Also, we included the most important information. The next thing that we included the sentences from the examples for this prompt. And that could also give the model the intuition how to extract skills. We understand that, and it is mentioned in the further research directions, that harder prompts and not harder, but maybe more information, more self-validation could yield better results. Yeah, and that could be a research direction, but also cost effectiveness should be the consideration, because
just stop speaking about the money. We're not in business administration. We're in computer science. So, thank you. More questions?
Thank you for your talk. I have few, bit more than few questions. So my first one would be like, from my understanding, you have this ESCO database where you have the description and you have skill specific one. Why do you use LLMs to extract it and not to use just like regular parsing from the string? If you have like exact base and you know what to search for. If you don't searching for the level or some description, you're just searching for Python, let's say, or JavaScript.
Yeah, if we are talking about Python, as it formerly Python word, we can search like for this word. If we have like 15,000 skills, it would be harder to search. But yeah, we can like think about algorithm like that. But we want to train model not to just select the skills that are in ESCO. We want to train the model to select the skills which follow this. Follow these rules, the definition, and the original data set actually like was labeled following this rules, not following the not just by simply trying to find skills from ESCO in the data in the like job posting.
Okay, thank you. So my next question would be about the distributions. So you have the ChatGPT or whatever language model that generates you the synthetic data set in that size that you want. It samples it from the distribution of the data set it was learned on. Yeah. So when you train the model on top of it, basically you distill the knowledge from the ChatGPT in some way and getting some other information. So you're saying that increasing the data set size uh, of synthetic data set
Yeah.
increases the quality of your model at some point.
Yeah, that's what we observed.
Yeah, you observed. So my question would be, like, if you have the limited distribution and sampling more points from this distribution, basically adding more samples, you are not getting like the new distribution from the original model. Like, what maybe it's not improving, maybe it's improving just, but to some limit, and you didn't reach that limit.
So of course we cannot improve like infinitely. I bet we improved it, yeah, to some limit, and as we can see from this slide, so we kind of um, reached that limit, and then started our performance started to degrade. Um, so. So could you please like
Yes.
repeat the question?
So my question is that you stated that you're serving increasing of from increasing the dataset size, and then you got degradation of performance. But actually, it's not like the increasing of the quality. It's just like you're reaching the distribution from the data that was fed into ChatGPT and trained on, and that's all. So you can't get out of the distribution because it limits you from all sides. The model can't provide you the new samples out of the distribution.
I think I get what you're talking about. Yeah. Yeah, that is probably the case, like here, that we reach the data, the knowledge, let's say the.
Okay.
Okay. Yeah.
So the next one would be about the leakage. So you don't know on what data set the ChatGPT was trained on. What includes it? Like it, as for me, I think it's trained on all entire internet. And when you're saying that you distilled the data, no, let's say distilled from the ChatGPT, trained the model, and evaluated it on the data set from the internet, are you sure that this data set was not included in the training set of ChatGPT?
I cannot be sure about it.
So it's possible that your results that you're reporting are leaked.
Yeah, there is a possibility like that.
And how to guarantee that reporting of such results would not have a leak?
We cannot guarantee it.
You can train your own language model.
Or something like that. Yeah.
And one more thing, like just small comment. If you said at the end that open source models are not good enough, addressing the comment of reviewer. So you benchmarked them, or how did you decided that open source is not good enough? Like there's a chatbot arena, which has results, and there's a lot of open source models in the top.
Yeah. So we tried Llama 2 at the beginning, like of our research. I tried, and I tried using the same prompts that like I had the GPT models, and it if we are talking about these problems, irrelevant detection, small formed response, merged entities, probably more even like not followed the instruction correctly, like didn't return just the sentence, but also additional texts around this sentence. We found that these results were like far worse than the models that we have, the closed source models. And we decided to focus on them.
Okay, thank you.
Yes. So also just a follow-up question, as it following what Ihar was saying. For example, when we work with the models and we are focused on having the highest performance. For example, as in your case, you reach some level, and then the next step is usually understand on what examples does my model work, on what example does it doesn't work, on what examples, for example, the models that wasn't trained on synthetic data work, on what example it doesn't work. So have you performed such type of analysis just to understand uh, what are the gains of synthetic data?
We looked, I looked at the results of the model, like the output, and but it wasn't included in my research. Yeah, so I can say that it's a topic for the follow-up research.
Okay. No more questions?
Okay, in general, to make a long story short, looks like one more work with I tried this, but it fails. I tried another, but it get bad results. Why LLM? For me, it's not obvious that it should get good results at the very beginning, not trying anything, just as an intuition. It shouldn't get good results. Hallucinations, we heard a lot of work today and many other issues which was pretty sure will get bad results.
So be, before the research, so during the literature review, we found several papers that utilize LLM. For example, training for text classification, generating synthetic data to train for text sentiment classification. So It was also mentioned that LLMs were used like for several others approaches due for skill span recognition and yielded good results. So we decided to try this approach for this problem.
It reminds me like a joke that LLM understands the text. Like we know from the Gödel theorem that you should avoid go out of the system to another level to speak about some kind of understanding. It's pretty just impossible to understand. So I see it like the same situation, but understand. Thank you.
No more questions. Thank you, Andrei.
Thank you.
We need 15, 20 minutes to up to half an hour to aggregate and resolve all the conflicts and then announce the results.